Alrighty, this is the video for Math 102 and 102 lecture and online. I thought I would cover a couple of things. I'm going to try to cover several sections with this video, with giving you examples of each one. The first one is 6.1, and I covered this in the class video the other day, but this is basically reducing rational expressions. A rational expression is nothing but a complex fraction. Rational expression is nothing but a nasty, complex fraction. That's all it is. Back in pre-algebra, you had 2 over 6. You had 3 over 15. And you had 1/4 times 16 over 17. And you had, different types of, let's see, 1/4 divided by 2/3. And those are just some, simple examples. Here, you were told to reduce. 2 we're going to 2 one time, 2 we're going to 6 3 times. So the answer is 1/3. 3 will go into 3 one time, 3 will go into 15 5 times. So that's 1/5. These are basic, very basic. And we did this in class the other day. Here, 4 we're going to 4 one time, 4 we're going to 16 4 times. 1 times 4 is 4. And 17 times 1 is 17. And here you multiply by the reciprocal, which is 3/2. And you can't cancel anything, so you just 3 over 8. These are all basic rules to reduce. Multiply and divide with rational expressions or complex fractions, or basic fractions. This is your complex. X times, let me start over. X squared plus x over 2x. And what do we do here? Well, you can't do anything except for factor out a common term up here. It's got 2 terms like we talked about in class. Flag is factor out a common term, or shortcut. Shortcut number 3 usually. In this case, we factor out a common term, which would be x. And you get x plus 1 over 2x. And these are single, so they can pretty much cancel out. Can't cancel with this guy because he's married to the 1. The 1 and the, if you have a minus or a plus here between the two, they can't do anything. They're in a block. And that's reducing. We just reduced this one down to x plus 1 over 2. So we just did this type of canceling with this problem. Alright, let's do another one. Let's do a multiplication. X plus 2 over x times x to the 4th over x plus 2 squared. Well, cancel it just like you did back in pre-algebra. X will go into x one time, x will go into x to the 4th, x to the 3rd times. Oops, this is to the 1st power, so that'll go in there one time. Go in here, x plus 2 to the 1st power. So 1 times x to the 3rd is x to the 3rd, and 1 times x plus 2 is x plus 2. And you have to put those parentheses because you cannot cancel these two x's because they're married. These two are married. It's got a plus or a minus right there. And that one is just like this one. Division. And I'm putting a couple of sections together here because the first two sections, 6.1 and 6.2, is reducing, multiplying, and dividing. So, x squared plus 4x plus 4 over x minus 1 divided by x plus 2 over x squared minus 1. Alright, well, you learned back in pre-algebra, basic math, that if you divide by a fraction, you multiply by the what? Reciprocal. So rewrite, and go ahead and factor this. That's shortcut number 1. So it'd be x plus 2 quantity squared over x minus 1 to the first. And I'm just doing that just so you can recognize that this is one thing. Multiplied by x plus 1, x minus 1 over x plus 2. I just flipped it over. This comes up and this comes up, and that's shortcut number 3. And then this will cancel with that. This will cancel with one of these. Leave that to the first. So your answer is x plus 2 to the first power times x plus 1 to the first power over 1, or x plus 2 times x plus 1. Now you could use your FOIL method here, but there's no need. It cannot be marked wrong, but this is probably good enough for government work. So, and again, you divided by a fraction, you multiply by the reciprocal, just like you learned back in pre-algebra. Now, this will take us to pretty much, don't forget to set the denominator equal to 0. If you ever given an expression, x squared plus 4x minus 2 over x minus 4. The first thing you do when asked, you may be asked about the domain or the numbers used in expression. Some type of directions will be something about what numbers can you use in the expression, or what is the domain of the expression. Any fraction, and I'm going to write this in red, any fraction can not have 0 in the denominator. Period. Alright? And you've got to remember that in all your math classes that you take, because it will get you if you forget it. So whenever you're given a rational expression, always set the denominator equal to 0 to find the bad number. In other words, the number that will blow up the function or make it not work or make it undefined. So x minus 4 is equal to 0, x is equal to 4. That means if you plug in a 4 into this expression, it will put a 0 in the denominator and it will not be defined. So you can use all numbers except x cannot equal 4. And that's how you find what numbers you can use for your expression. Always set the denominator equal to 0. And that's also in 6.1/6.2. I think I'm covering 6.1 to 6.3. 6.4 and 6.5 I think is adding and subtracting fractions. But before I do that, I'd like to go back to pre-algebra and talk about adding and subtracting fractions. Well, I want to make sure everybody knows how to do the basics before we get into the heavy stuff. So 1/2 plus 3/4. Now, a lot of students would say, oh, 8 is the common denominator. Well, you're wrong. Okay? The way that you find the common denominator with numbers is you put a 2 here and a 4 here, and you 2, 3, 5, 7, 11, and sometimes 13. You use those numbers to get 1s on the bottom. When you get 1s on the bottom, then you have the common denominator. So 2 divided by 2 is 1, 4 divided by 2 is 2. 2, we got 1 that comes down, and 2 divided by 2 is 1, so we're done. And there is your common denominator. So your common denominator is 4. So now you convert the numerators. 2 will go into 4 2 times. 2 times 1 is 2. 4 will go into 4 1 time. 1 times 3 is 3. Now, if you need to rewind the video and go over that 3 or 4 times, excuse me, do that now, because this is very important. 2 will go into 4 2 times. 2 times 1 is 2. 4 will go into 4 1 time. 1 times 3 is 3. And then 2 plus 3 is 5. And that's your answer. And I always get people to ask me, well, don't that need to be a mixed number? No. Mixed numbers are only used with units of measure. Units of measure. Cups, miles, grams, centimeters. You don't walk into Walmart and ask for 5/4 feet of rope. You ask for 1 1/4 feet of rope. So mixed numbers are only used with units of measure. Units of measure. Alright, so when you have a mixed, you have two different numbers and they're composite, then you need to do this. If they're prime, you multiply them together. 1/2 plus 3/7. The common denominator is 14. And then you convert. 2 will go into 14 7 times. 7 times 1 is 7. 7 will go into 14 2 times. 2 times 3 is 6. 13/14. Alright, so there's a little brush up of pre-algebra. And, well, basic math. And then you go into pre-algebra. And you find out that you get 3 over x plus 4 over x squared. Well, when you're finding a common denominator, and we've talked about this in class with factoring, when you're finding a common denominator, you always go with the highest exponent. Remember that, because when you factor out a common term, you use the lowest exponent. And we did that in the last couple of classes in the lecture. We've done that. So remember, when you factor out a common term, you use the lowest exponent. When you find the when you find the common denominator, you use the highest. So this will be x squared. And x will go into x squared. X times 3 is 3x. X squared will go into x squared one time. 1 times 4 is 4. Your final answer is 3x plus 4 over x squared, and you cannot cancel because these two are married. And that's a pre-algebra problem. Now, what if you have two denominators with variables that are prime of each other? These are composite. This is composite of this one. In other words, this one will go into this one, so you use the highest exponent. What if you don't have common denominators or prime denominators? Let's go with 3 over x plus 4 over y. These two have nothing in common. So what did you do back in pre-algebra when you had two prime numbers? You multiplied them together. Now with numbers, you multiply them together and get another number. But with variables, you just have x, y. So I'm going to multiply them together, and there is my common denominator. How many times will x go into x, y? Y times 3 is 3y. How many times will y go into x, y? X times 4 is 4x. So your final answer is 3y plus 4x over xy. And again, you cannot cancel because these two are married. Okay, so now we're up into a little bit of pre-algebra, algebra 1. Let's try this one. 4 over x plus 1 plus 7 over x plus 1 squared. Now we're going to go back to previous problems. Here's one. Same base, different exponents. You go with the highest exponent. So the answer here, the denominator is x plus 1 squared plus x plus 1 squared. How many times will this go into this? Well, x plus 1 to the first power, because x plus 1 to the first power times x plus 1 to the first power is x plus 1 to the second. You add the exponents. Times 4 is 4 times x plus 1. X plus 1 squared will go into x plus 1 squared one time. 1 times 7 is 7. So your final answer, or not final, but 4 times x plus 1 plus 7 over x plus 1 quantity squared. Distribute this 4. You get 4x plus 4 plus 7 over x plus 1 quantity squared. 4x plus 11 over x plus 1 quantity squared, and that's your final answer. So you're using the same properties that you learned. You have two numbers. Well, usually if they're two composites, you go with the highest. You have the same base, you go with the highest exponent. And if you have the same base, you go with the highest exponent. So that same principle applies with basic math, pre-algebra, algebra 1, and it's going to be with algebra 2 also. What if you have two that are prime of each other? Well, in basic math, you multiply them together. In pre-algebra, you multiply them together. And in algebra 1, you multiply them together. 1 over x plus 1 plus 3 over x minus 2. Now these two have nothing in common. Yeah, they have x in common, but they're married. So these two have nothing in common with these two. So you put them together. X plus 1 times x minus 2. X plus 1 times x minus 2. That is the common denominator, just like your 21 or your 14. You have a 2 here and a 7 here, then your 14 is your actual common denominator. So how many times will x plus 1 go into this denominator? X minus 2 times. X minus 2 times 1 is 1 times x minus 2. How many times will x minus 2 go in here? X plus 1 times. X plus 1 times 3 is 3 times x plus 1. So now we've got x minus 2 plus 3 times x plus 1. Oops, forgot my 1 there. Over x plus 1 times x minus 2. Now this up here we can clean up. We can clean up the numerator. So distribute the 1, distribute the positive 3, and we get x minus 2 plus 3x plus 3 all over x plus 1 times x minus 2. And x plus 3x is 4x, and negative 2 plus 3 is 1 over x plus 1 times x minus 2. Now, what's the big difference between the problems that we've been going over and the problems that we're doing now? Well, the problems that we're doing now are going to have trinomials in them. You're going to have complex rational, or whatever you call them, messy fractions, complex rationals, along with trinomials. Now, a trinomial in this chapter is worth nothing unless you factor it. You need to write that down. In this chapter 6, with what we're doing, if you have a trinomial, more than likely, unless you can cancel it with another trinomial, you are going to have to factor it using the reverse FOIL or your shortcuts. So what's the difference between most of yours? Here it is. This is the difference. Here I'm going to get, I don't know, x plus 4 over x squared plus 4x plus 4 plus 3 over x squared minus 2x minus 8. Okay? Now, you've got two trinomials here. They're in the denominator. So you got to get a common denominator. But before you do anything, you got to factor them because they're worthless. Trinomials are worthless in this section unless you factor them. So x plus 4 over shortcut number 1 gives you x plus 4 quantity squared plus 3 over x reverse FOIL, because this is not a perfect square and the signs are not correct for a shortcut. X, 2 and 4 and a negative 4 and a positive 2. Now, can you reduce anything? Yes, over here you can reduce this down to 1 over x plus 4 plus 3 over x plus 2 times x minus 4. Now you're ready to get a common denominator. The common denominator of all this is basically all this, because you've got 7x over here and you got a 3 over here. If you got a 7x over here and a 3 over here, your common denominator is 21x. So you're going to have to put them all three together. So that would be x plus 4, x plus 2, x minus 4, plus x plus 4, x plus 2, x minus 4. How many times will x plus 4 go into this? That many times. So that would be 1 times x plus 2 times x minus 4. Now, I'm not writing my arrows here like I was before, okay? Because it'll make it all messy and I didn't want to do that. But you're doing the same thing. X plus 4 will go into this many times. This times 1 is this. How many times will this go into this many times? 3 times x plus 4. And now we finish up. Everything's going to be over the common denominator, x plus 4 times x plus 2 times x minus 4, x plus 2 times x minus 4 plus 3 times x plus 4. And now you use the FOIL method here, distribute, combine like terms, clean it up as much as possible. So this is going to give you x squared minus 2x minus 8 plus 3x plus 12 all over x plus 4 times x plus 2 times x minus 4. And the 2x and 3x will combine, and that'll give you x squared minus 2x plus 3x is positive x, minus 8 plus 12 is positive 4, over x plus 4, x plus 2, and x minus 4. And I don't think that's factorable because 1 and 4 and 2 and 2 will not give you 1. So that is your final answer. Now, what I would suggest is that you take a look at this video 2 or 3 times, because not only are you bringing up stuff from basic math and pre-algebra, but you're building step by step on each one of these properties. And I would highly suggest that you watch this video a couple of times before you actually get started on some of your homework problems. Hope this helps.